and welcome to Programming C course. In lesson number 3, we will cover Introduction to Array, Variable Declaration, Expression, Statement, Assignment Statement, Reading Data, Symbolic Constants, User-Defined Data Types, Storage Class, and Type Qualifiers. Introduction to Array. An array is an identifier that refers to a collection of data items of the same data type that share a common name. All the data items of the array should be of the same data type. They all may be integer data type or character data type or floating point data type or double data type, and they should share a common name. The individual data items are represented by their corresponding array elements, which are distinguished from one another by their subscripts. For example, suppose that x square bracket 10 is a 10 element array, then the first element is denoted by x square bracket 0, the second by x square bracket 1, and so on. The last element will be denoted by x square bracket 9. Why? Because the subscript of our first array element is 0, not 1. One-dimensional character array. One-dimensional character array is generally used to represent a string. A string is a collection of characters. Each array element will represent one character within the string. If the array contains n elements, the subscript will be an integer quantity whose value ranges from 0 to n-1. 1 less than n, because our subscript starts from 0, not from 1. Note that an n-character string will require an n+1 element array because of the null character that is automatically placed at the end of the string by the compiler. We have to reserve one place for the null character at the end of the string. So, to store an n-character string in an array, we will require an array of size n+1. For example, suppose that the string info is to be stored in a one-dimensional character array called city. Since info contains 6 characters, city will be a 7-element array. The 7th element will be the null character, which indicates the end of the string info. We will look into this in detail in the next slide. Now the array city will have elements from 1 to 7. The subscripts of the array elements will be from 0 to 6. The array elements will be denoted by city square bracket 0, city square bracket 1, and so on. And the corresponding data items stored in the array city are I, M, P, H, A, L, and the last character will be the null character. So the character I will be stored in city square bracket 0, M in city square bracket 1, and so on, and L in city square bracket 5, and the last character, null character, will be stored in city square bracket 6. Variable declaration. I have already told you about how to declare variables in the last video. Here I will tell you more about variable declaration. All variables must be declared and defined before they can appear in executable statements. There is a difference between declaration of variable and definition of variable. When we declare variable, we are just declaring that these variables will be of a particular data type and we will be using these variables later in the program. But no memory is allocated by the compiler. But when we define a variable, then memory is allocated for that variable. So that is the difference between declaration and definition of a variable. A declaration associates a group of variables with a specific data type. It consists of a data type followed by one or more variable names and ends with a semicolon. When declaring an array variable, each array variable must be followed by a pair of square brackets containing a positive integer which specifies the size of the array. Examples of variable declaration are char flag text square bracket 80, Here, flag is a char data type and it can store a single character constant. And text square bracket at is an array of char data type. It can store a string of characters having a maximum of 79 characters, because the last element of the array will have to be the null character to indicate the end of the string stored in the array text. The next declaration is int ABC. Here we are declaring the variables ABC to be of data type int, which means ABC are signed integers. Even though the keyword sign is not mentioned here, by default int data type are treated as signed integers. The next declaration is sort PQ. Here the variables PQ are sort integer data type, because when data type qualifiers sort, long, unsigned are used without the basic data types, those variables are treated to be by default int data type. So the variables PQ are sort integer data types. Similarly, the next declaration is long RST without any basic data type. Long is a data type qualifier, so by default RST will be treated as long integer data type. The next declaration is unsigned XY. Here also data type qualifier unsigned is used without any basic data type. So by default the variables XY will be treated as integer data type, and therefore the variables XY are unsigned integer data types. The next declaration is float root1, root2. Here the variables root1 and root2 are floating point data types having 6 digits after decimal point. The next declaration is double C1, C2, C3. Here the variables C1, C2 and C3 will be double floating point data type having 15 digits after the decimal point. Assigning initial values during declaration. Initial values can be assigned to variables within a type declaration. To do so, the declaration must consist of a data type followed by a variable name, an equal sign and a constant of the appropriate type. A semicolon must appear at the end as usual. For example, in the statement int c equal to 12, the variable c is being declared to be of int data type, and at the same time the value 12 is being assigned to the variable c. The next statement char star equal to single quote star declares the variable star to be of char data type, and at the same time it is being assigned the character constant star. The next statement float sum equal to 0 point semicolon declares the variable sum to be of floating point data type, and at the same time it is being assigned a floating point value of 0 point to the variable sum. The next statement double factor equal to 0.21023 exponent minus 6 semicolon declares that the variable factor is of double floating point data type, and at the same time the variable factor is being assigned the initial value of 0.21023 exponent minus 6. A character type array can also be initialized within a declaration. To do so, the array is usually written without an explicit size specification. The array name is then followed by an equal sign, the string enclosed in double quotes, and a semicolon. For example, char city empty square bracket equal to within double quote infal semicolon. This statement is declaring that the variable city will be an array of characters without specifying the size of the array, and at the same time the initial string constant infal is being assigned to the array city. Expression. What is an expression? An expression represents a single data item such as a number or a character. An expression may consist of a single entity such as a constant, a variable, an array element, or a reference to a function, or a combination of entities interconnected by one or more operators. An expression can also represent logical conditions, that is either true or false. However, in C, the conditions true and false are represented by the integer values 1 and 0 respectively. Hence, logical type expressions rarely represent numerical quantities. For example, A plus B is an expression consisting of two data items A and B interconnected by an operator plus. When evaluated, its value can either be a number or a character. Similarly, x equal to y is an expression consisting of two data items x and y interconnected by an operator equal to. When evaluated, its value will either be a number or a character. Similarly, C equal to A plus B is an expression consisting of three data items A, B, C. When evaluated, this expression will represent either a number or a character. Similarly, x less than or equal to y is an expression consisting of two data items x and y interconnected by the relational operator less than or equal to. Its value can be evaluated to be either 1 or 0. 1 in case if it is true and 0 in case if it is false. Similarly, x double equal to y is an expression consisting of two data items interconnected by the double equal to sign. Here we are comparing whether the two data items x and y are equal or not. Remember, a single equal sign represents the assignment operator while a double equal sign represents the equality operator. The value of the expression x double equals to y will be 1 if x and y are equal and 0 if x and y are not equal. And lastly, plus plus I is an expression consisting of a single data item I along with the unary increment operator plus plus. The expression plus plus I is equivalent to I equal to I plus 1, which means increase the present value of I by 1 and store that value to I again. The operator plus plus, which indicates incrementing, is called a unary operator because it has only one operand I. Similarly, we have minus minus unary operator, which we will be covering in the next chapter. Statement. A statement causes the computer to carry out some action. There are three different classes of statements in C. The first one is expression statement. The second one is compound statement. And the third one is control statement. Let's see these one by one in the coming slides. First, the expression statement. An expression statement consists of an expression followed by a semicolon. The execution of an expression statement causes the expression to be evaluated. So, whenever an expression is followed by a semicolon, it is called an expression statement. For example, A equal to 3 is an expression. When it is followed by a semicolon, then it becomes an expression statement. When this statement is executed, the value 3 is assigned to the variable A. Similarly, the expression C equal to A plus B becomes an expression statement when it is followed by the semicolon. When this statement is executed by the compiler, the value of A plus B is assigned to C. Similarly, plus plus I followed by a semicolon is an expression statement. It increases the present value of I by 1. Similarly, the expression printf within parentheses double quote area equal to %f comma area when followed by a semicolon becomes a statement. When executed, this statement prints area equal to followed by the value of the area on the monitor. Lastly, a single semicolon is also an expression statement. This statement is called a null statement because it doesn't do anything. The second kind of statement is the compound statement. A compound statement consists of several individual statements enclosed within a pair of braces. The individual statements may themselves be expression statement, compound statement, or control statement. Thus, the compound statement provides a capability for embedding statements within other statements. Unlike an expression statement, a compound statement does not end with a semicolon. For example, within the braces, we can see three expression statements. The first expression statement is pi equal to 3.141593 semicolon. The second expression statement is circumference equal to 2.0 multiplied by pi multiplied by radius semicolon. The third expression statement is area equal to pi multiplied by radius semicolon. These three expression statements are enclosed within a pair of braces. Therefore, the collection of these statements is known as a compound statement. The third kind of statement is the control statement. A control statement is used to create special program features such as logical tests, loop, and branches. A control statement requires other statements to be embedded within it. For example, here we are seeing a section of a program called while loop. This will be covered in later lessons. The statement while within parentheses count less than or equal to n is called a control statement because it controls the number of times the expressions within the braces will be executed. The four expression statements within the braces will be executed as long as the value of the count is less than or equal to n. Therefore, while within parentheses count less than or equal to n is called a control statement, and the four expression statements within the braces together is a compound statement. Next, let us see what is an assignment statement. A variable can be assigned a value using the assignment operator equal to as follows. Variable underscore name equal to constant, where constant is a character constant or a numeric constant, and it is being assigned to the variable underscore name by the assignment operator single equal to. C permits multiple assignments in one line. For example, initial underscore value equal to 0 semicolon, final underscore value equal to 100 semicolon. In one single line, we're assigning the values 0 and 100 to the variables initial underscore value and final underscore value respectively. An assignment statement implies that the value of the variable on the left of the equal sign is set equal to the value of the quantity or expression on the right. The statement year equal to year plus 1 means the new value of year is equal to the old value of year plus 1. During assignment operation, C converts the type of value on the right hand side to the type on the left. This may involve truncation when real value is converted to an integer. It is also possible to assign a value to a variable at the time the variable is declared. This takes the following form: data type variable name equal to constant, where the data type specifies the data type of the variable name, and at the same time the value constant is being assigned to the variable name. Next, what is an initialization? The process of giving initial values to variables is called initialization. C permits the initialization of more than one variables in one statement using multiple assignment operators. For example, the statement P equal to Q equal to R equal to 0 assigns the value 0 simultaneously to the variables P, Q, R. The next statement X equal to Y equal to Z equal to max assigns the value represented by the symbolic constant max to the variables x, y, z simultaneously. Note that max written in uppercase is a symbolic constant defined at the beginning. We will cover symbolic constant in the later part of this lesson. But for now, just remember that max written in uppercase is a symbolic constant defined at the beginning. Now, besides assigning a value to a variable using assignment operator, we can also read data from keyboard using scanf function. Scanf function is a library function provided in the header file stdio.h. So another way of giving values to variables is to input data through keyboard using the scanf function. The general format of scanf is as follows: scanf within parentheses double quote, within the double quote there will be control string, and then the variables for which the values will be obtained from the keyboard will come one by one, each variable preceded by an ampersand sign. Here the control string contains the format of data being received. The ampersand symbol before its variable name is an operator called address operator that specifies the variable name's address. For example, scanf within parenthesis double quote %d, comma, ampersand number. Here, the value of the variable number is being obtained by the scanf function from the user through the keyboard, and the number being obtained is to be stored at the memory address of the variable number, and that address is being indicated by ampersand number, and the %d within the double quote indicates that the value the variable number is supposed to obtain is to be of integer data type. If the scanf function contains more than one variable, the values entered should match the order and the type of the variables in the list, which means if the values of several variables having different data types are to be read using a single scanf function, then the order and the type of the variables has to be strictly followed. Any mismatch might lead to unexpected results. The compiler may not detect such errors. Alright, for a change, let's write a C program in Turbo-C compiler. I'll tell you about how to create a new .c file, how to open a C program, how to write a C program, how to save a C program, how to compile a C program, how to debug a C program, how to run a C program. So let's open Turbo-C compiler in our desktop or laptop and write our first C program. Now launch your Turbo-C compiler in your desktop or laptop. Then click on Start Turbo-C++. Then you will see the Turbo-C compiler window like this. Go to File and click it. Then click on New, since we are going to open a new file. Now our compiler has opened a new file. Before writing our program, let us first rename this file. Click on File, then click on Save As. Here you give a name of your C program file. Today let us write a C program to calculate the amount at the end of a certain number of years at a given rate of interest, not compounded. So let us give the name of our program is amount.c. Remember, since we are writing C program, we have to always include the file extension .c in the name of the C program we write. Then click OK. Now we have renamed the new file as amount.c. Now here we can start writing our C program. Has include less than stdio.h greater than int main opening braces 3 space. Let us declare the variables we are going to use in this program. First, I'll be using a variable period of data type in to denote the number of years. Then I'll be using variables amount of data type floating point, then red, and end the statement with a semicolon. Remember, every expression statement should be ended by a semicolon. Then let us print enter the values of amount, rate, and period. The period should be in years. Give a space, closing double quote, closing parenthesis, then end with a semicolon. Then we write the scanf. I am writing this program to illustrate the use of the library function scanf to read data from the keyboard. Within double quote, we have to write the control string. Now let us see what are the data types of the variables we are going to read from the keyboard. The first one is amount. Amount we have declared as float, so we have to write %f to indicate float. The next one is rate. Again, rate has been declared as float data type, so we should write %f. The next variable we're going to read is period, and period has been declared as int data type, so we should write %d, then closing double quote. This ends the control string, which specifies the data types of the variables to be read from the keyboard, then comma. Then we have to write the name of the variables. It's preceded by an ampersand sign. The first one is amount, so ampersand amount, ampersand rate, and then ampersand period, then the closing parenthesis, and end with a semicolon. Remember, here the ampersand symbol before the variables amount, rate, and period indicate the memory address of the variables amount, rate, and period, where the values we are going to read from the keyboard is to be stored. After reading the values of the variable amount, rate, and period, now we can start calculating the amount at the end of the inputted period at the given rate. So amount equal to amount plus amount into rate divided by 100 multiplied by period. This will end with a semicolon. Now let us print the final value of the amount. Now printf, whatever we want to print, it has to be put inside the double quote. So the amount at the end of, here we want to mention the period, so we'll be writing %d, as period is integer data type. %d is a placeholder for the value of the variable period, and years is rupees. Then here our amount will come, so we will have to write a placeholder. Since our amount is floating point data type, we should write %f. It will have 6 digits after the decimal point, but when we write money, there should be only 2 digits after the decimal point, so we have to restrict the number of digits after the decimal point. Therefore, before f we have to write 0.2, which means that after the decimal point there should be only 2 digits. So we enclose this statement we want to print by the double quote, then comma. Now in the placeholders occupied by %d and %.2f, we have to print the values of the variable period. We write period and amount, then the closing parenthesis, then ends with a semicolon. Here we have finished writing our C program. Now we can end this program by a return 0 statement. Then we have to end this program by the closing braces. Now after writing your C program, before compiling it, you have to save it. So let us go to file and save, or you can press F2 to save your program. Remember to save your program before you compile your program, because when you write a program there may be lots of errors which you may not notice, and while trying to compile the program, because of those errors the compiler might fail to compile your program, and in that process if the compiler is stuck or goes into an infinite loop, then you will lose all whatever you have typed in your program. So don't forget to save your program before you compile. After saving your program, you can compile your program. Now to compile your program, go to compile and click on compile, or you can press Alt F9 from your keyboard. So let us click on compile. Now our program has compiled successfully and there is no error, so we can press any key to exit the compilation process. Now after the program has been compiled successfully, we have to run the program to see the outcome of the program. So to run the program, let's go and click on the run menu, then click on run, or either you can press Ctrl F9 from your keyboard. Let's click on run, and our program has been executed, and it is telling us to enter the values of the amount, rate, and period. Let us enter an amount of 1000 rupees, which we want to invest at the rate of 10% per annum for a period of 2 years. Remember, when you read more than one variable, using a single scanf function, then the order in which the values of the variable are entered from the keyboard should match the order of the variable in the scanf function. Here the order of the variables are amount, rate and period, and accordingly the value of the amount, rate and period has to be entered from the keyboard, and the values 1000, 10 and 2 has to be separated by a space. After you have entered all the values, then you can press enter. Now the compiler has returned back to our program. To see the final result or the final amount, we have to press Alt F5 to see the console window, and the last line the program has printed is the amount at the end of 2 years is rupees 1200, which is correct because 10% of 1000 for 1 year is rupees 100, and for 2 years it is 200, and if the interest 200 is added to the amount 1000, then the amount at the end of 2 years will be rupees 1200. See here, the number of digits after the decimal point is 2 because we have restricted the number of digits after the decimal point in the printf statement by writing .2 before F. That's it. We have written a C program in Turbo-C compiler. We have saved it by giving a name. We have compiled it. We have run it. Now to go back to our program, we have to press escape button in our keyboard. Let's press it. Now we are coming back to our program window. Now in case there is any error in our program, then it will be shown in the window below. Now correcting those errors is called debugging. Now I will commit a deliberate mistake in our program. When we write the name of the variable rate, suppose I miss the letter E, then I try to compile by pressing Alt F9, then it is showing one error. To correct this error or to debug this program, I have to press any key, then the line where the error is highlighted, and in the message window below the error is being highlighted. It is saying that the variable rate is undefined and undeclared in the program. It is true because the name of the variable we have declared and defined is rate, and in the scanf function what we are using is rat. Those two are different. Without declaring a variable, we cannot use inside the program. So to correct this error, let's go and double click where the error is. Then we can correct our error. After that, save your program. Then compile it again by pressing Alt and F9. Now we have corrected our error, and this process is called debugging. Debugging means correcting the errors in our program. Now after you have corrected all the errors, you can run your program and check the values being printed on the monitor to see whether the program has correctly calculated the amount it is supposed to calculate. Now how to close the program we have written and open it again. Now to close the program we have written, we have to press Alt key and F3 simultaneously. Now I am pressing Alt and F3 simultaneously, so our program amount.c has been closed. Now to open our program amount.c again, either we can go to File and click Open or press F3 from our keyboard. Now let me first go to File, then click on it, then you can see Open here. If you click on Open, then this window will come out. Now in the list of the files below, we can see the program we have written just now, amount.c. Click on it, then click on Open, then it will be open. Let's do it again. This time I'll use the shortcut. To close this program, I have to press Alt F3 and it has closed. To open the program, I can press F3 from our keyboard. Then this window will come off. Then click on the list of the files below and search for your file. Click on it, then click on Open. Then your program will be open. Now before quitting the Turbo-C compiler, we have to close our C program. So press Alt F3 to close your C program. Then you can quit the Turbo-C compiler by pressing either Alt X or go to File and click on Quit. Then you have exited from the Turbo-C compiler. You can close this window. This is the program we have written in our Turbo-C compiler and run it successfully. Now it's your turn to write simple C programs to solve simple numerical problems. Good luck and all the best. That's all for now. Thank you everyone.